All right, so I'll share my screen. Let me know if you can see it.
Yes, sir, it's visible.
Right, perfect. Okay, so this will be an AS level physics course. So we'll be covering the topics that are included in AS levels physics. And so I'll tell you everything, how we'll carry forward with the course and all. But I'll just start by introducing myself. My name is Basil Abdul Majid, right? And I am a theoretical physics graduate from NUST in Pakistan. From NUST, and I have a roundabout of you can say 5 years of teaching experience as well. So I'll just use T.E for teaching experience. And I've been also working as recently as a graduate teaching assistant in the physics department of NUST, where I've been solving some problems, giving some classes and problem solving sessions, and we call them recitation sessions and all. So that's me. And well, my research interests, because I'm a theoretical physics graduate, my research interests are theoretical particle physics, quantum field theories, especially, and gauge theories of gravity, and so on. So, well, yeah, so that's basically me. And my interest in physics developed during my O levels, especially during the end of O levels and the beginning of A levels, actually. So it started basically with me just watching some random videos on YouTube. And then I just came across this video of Sir Isaac Newton. There was a very nice documentary on him, and I watched it for the fun of it. And it turns out I was very intrigued by that documentary. And then it led on to another documentary by Albert for Albert Einstein, and from there a lot of more videos and all. So I started reading books, especially it started with popular science books and all, and then moving on, Feynman and all those other really big names in physics. uh, I started reading them and reading about their work and so on, and that sparked the interest. And then that's when I decided that if I'll be anything, that will be a theoretical physicist. So yeah, so that's me. I would also like to know from where you guys are, what time zones are you following, and you can even say your names as well. And I hope that there is no hesitation in speaking. But if there is, then you can just type in chat, and I can check from there. Okay, so I'll have to open chat from here. Right. Okay, nice, nice, very nice, very nice, Sri Lanka. Amazing. Okay, good, good. So nice, nice, amazing. So you guys are giving your exams in October, November, or May, June? I mean, October, November, this session, or the or next year, both AS and A2 together in 2023, May, June. Right. Okay. 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 So doing my AS and A2 together as next year. Right. Okay. Okay. Amazing. So both are doing similar. Okay. So okay, there's this problem that I'll have to read your chat. I'll have to open it from here, which is I won't have any notification if you have said anything. So I'd prefer if you guys can speak and like, you know, because there's this one other problem as well, that I don't get the notifications for the chat, and so I'll have to check regularly. So it would be nice if you guys can speak as well while we're doing this. And okay, so with this next, let's move on to this thing. Let's discuss how we will be carrying this out. So this is just a demo lecture where I'll be mostly talking about giving you an introduction to everything, and we'll discuss how will this course, this thing go along the way. So let's start with how and what will we be doing on daily basis. So it's something like from Monday to Thursday, will be more or less focused on theory, right? And so we'll be solving examples and all. We'll also be doing some problems, but we'll discuss the theory part, where conceptual things and all of that, right? And then we'll be doing some examples and some problems as well. So that's that. And then for Friday is specifically reserved for your questions. Now, what I mean by that is we'll be solving past papers on Friday. And what you can do is, you'll obviously, when we're covering the topics in this theory part, you'll be having some questions. We'll be doing some examples, we'll be doing some problems, and you will have questions, right? So what you can do is, you can post those questions in the group on WhatsApp, right? And so you can do it. I prefer if you do it before Friday. So post all your questions. So up until Friday, then I can go through those questions myself, and then we can discuss it in the class on Friday. And so yeah, so that's that. I'll also be giving you homeworks, right? So after every topic or chapter that we have completed, I'll be giving you homeworks, and these homeworks will not be so lengthy and all of that, because I know that's scary, and so I don't want to scare you away, right? I'll be giving you homeworks. These homeworks will be testing your the knowledge that whatever I'll know what you understood from what I have been teaching, and so I can assess on that basis as well. I can assess my teaching style and what you have learned so far. And these will be given in the form of some let's say worksheets. Like, I'll prepare some worksheets, and I'll give you homework. We'll set a deadline, and so what I'm thinking is that after the deadline, I'll prepare the solution manual for those problems, and then I'll send you that solution manual. So what you can do is, you can grade yourself comparing it with the solution manual, and if you have any problems, that is what we have Friday for, right? So we can discuss those problems, questions, everything on Friday. Now, by saying this, I would also like to add that this does not mean that you cannot ask your questions anytime. There's no such thing like that. You can ask questions. You have questions, you can WhatsApp them in the group, and I'll get back to you as soon as possible. So far, for this thing, let's call it a timetable or whatever. Is there any question regarding what I have discussed so far? Okay, I think I'll have to go here and maybe you might have used chat. No, okay. Right. It would be nice of you if you can unmute yourself and just pronounce your names, so I can so when I say your names during the lecture or the class, I don't make any mistakes. So if you can do that right now, if you have if you have a source to if you have a mic or anything, you can just unmute and just pronounce your names.
So I'm Ishet. Well, most of
Yeah.
them call it in different ways. So I think Ishet. So if you spell Ishet, it would be great.
All right. Okay. Perfect. Perfect. Isha. Nice. Amazing.
Ah, yes, you got it correct. Yes.
Okay. Okay. Perfect. Right. So, okay. Let's get back here. Right. So, anyways, this is this. And then I'd also, at this point, I'd also like to say that your questions are always welcome. So you should always ask questions. You should not hesitate. My style, how I go about this thing is, what I do is I'd also be a student among you, and so I like to teach in that way. What that does is it would allow me to assess, or to even the questions that you would have, I would understand them better. So that's how I do it. So you can ask your questions. There will, because I'm sure that you'll have some questions, while again it might appear that you don't have any questions at the moment, but when you go back and go through all that we did in the class, you would, of course, you would be having questions, because I know that's how it is, right? You might think that yes, you understood everything, but when you go back to the notes and all, you'll be like, did when did we do this in the class, right? Sometimes that also happens. I've been a student, and so I know how that is. But anyways, so that's that, right? Okay. So I think, do you have is there any question regarding anything before we get into the chapter, the first chapter, first topic?
No doubts from my side, sir.
Okay, right. I think I'll chat box. Okay, right. So okay, so I guess then let's go a bit down this and. So we'll be starting the very first chapter, which is a very basic chapter. It's of measurements, physical quantities, and all. Very basic. I'm sure that you also have an idea of this thing in your O levels. You must have studied those. I'm sure that you study physical quantities in O levels as well, right?
Yes, sir.
Yeah. So okay, so we'll start with this thing, and it's pretty basic. So if I'm going too fast, or if I'm going too slow, you should let me know, so I can gauge my speed accordingly, right? So we'll start with chapter 1, measurements. And now, if I ask you, what in your opinion, how would you define a physical quantity?
A quantity that has both magnitude and a direction. Oh,
Both magnitude.
something that you can measure actually.
Yeah, exactly, right. So it's something that you can measure, or a much more neater, or the definition that I like is, It's what you use to write or represent your physical laws, or you can say laws of physics or laws of nature. So let me just give you a very a nice example. Suppose that at this moment you don't know what is force, what is distance, what is anything. What you do is you just see a block and you just push this block because you're curious, you want to see what happens, and this block moves towards the right. Now, to define or to understand the physics of what just happened, you need some variables. Now, those variables are called physical quantities. You just call them that these are physical quantities. So, for example, what would be one of the variables would be force, right? So this push that you gave to the block, you will call it force F, and then the block moved, right? So you would basically define this movement by saying that the block moved some distance d. So these are now your physical quantities or physical variables. And so that's what I meant by when I said that you can use you use these to write down or define or represent your laws of physics. Right. So anyway, so yes, so that's physical quantities. And so for every quantity, you you have their units as well. So let's come down over here. You see that we have a base quantities, and then we also have something that's called derived quantities. Now, base quantities are those which do not depend on any other quantity. So, for example, let's look at this one. We have length. Its SI unit is meters. Now, meters is not derived from any other thing. It's just the unit for length. It does not come from anywhere else. So it's you can think of it as it's the fundamental thing, and the symbol for that is m, right? Then you have mass, and mass is kilograms. Now again, kilograms is the SI unit, and it's a base. It's the basic quantity. So you can say that suppose you're making a pizza, and you prepare the base of the pizza first, and then you add the toppings on it, right? Everything, cheese, ketchup, or whatever you do, right? So that's those are your base quantities. So they are going to shape, or they're going to give rise to other quantities, which are called then your derived quantities. But if you look at this thing, kilograms now, gram is something separate and kilo is something separate, but not in terms of units. Not in terms of units. Basically, what I'm trying to say is when we move forward to the topic of prefixes, it will be much more clear at that point. But kilo is just a prefix, while gram is more like a unit. But the SI unit for mass, we use kilograms to represent the unit for mass, and that's K times G. So I said K times G, and you would understand what I meant by that also later on when we discuss prefixes. So that's kilograms. And similarly, you have more base quantities. You have time, which is seconds, and the unit is S. Similarly, you have these amount of substance, temperature, current, luminescence intensity, and these are their SI units. So I don't think that you have any problem at the moment. If you do, you should ask, right? So don't hesitate in asking questions. That's something that I'll keep stressing on throughout the course. So is there any problem at this point?
No doubts.
No. Okay, perfect. Okay, so then let's move on to derived quantities. Derived quantities are those which come from your base quantities. And it's not only that, these derived quantities can also come from more derived quantities. So for example, let me give you an example. You have acceleration. Acceleration is the change in velocity over time. Now, velocity itself is another derived quantity. So that's what I meant, right? So, but if you look at area, area is length times length. It's a two-dimensional thing. So you have meters and then you have meters. So this is a derived unit, meter squared. It's not a base unit. It's a derived unit, right? And another example could be of this volume. Volume is a three-dimensional thing. So you have three times you have this thing meters, and you get meter cube. I'm sure you understand because you have completed all your O levels. I'm sure you understand how do we get volume? Why is volume defined as length cube and why is area defined as length squared? It's simply because a volume exists in a three-dimensional space while area exists in a two-dimensional space. So to completely define an area, you need only two variables. So let's suppose they're x and y. But to completely specify a volume, you need three variables, which are x, y, and z. So when you combine these, you get, if you combine a two-dimensional thing, you get area. And if you combine a three-dimensional thing, you get volume, right? So I hope that's obviously, that's I'm sure that's clear. So yeah, so then we have more of these. We have density, which is defined as mass per unit volume. We have velocity, which is just the distance traveled or the length covered over time, and so on, right? So these are just, we are not going into the detail of these, what these quantities mean at this point. We'll discuss that in the upcoming chapters, right? Uh, at this point, we're just concerned with how these units or these quantities behave. Right. So similarly, we have more over here, and these notes will be shared with you. You can see all of these. You can even Google these quantities, and you can find their the equations. You can find the units and everything, right? So I'll move forward. There's no. Let me know. This is just another one, resistance, and it's the unit for this is this thing, but you can rename this into ohms, and so that's where you get ohms from. So anyway, is there any question up until this point?
All clear, sir.
Sorry.
It's all clear.
Okay. So yeah, again, you should, if I'm going too fast or if I'm going too slow, just let me know. I'm trying to get these topics covered because in my opinion, I believe that you're pretty familiar with these things. This, at least this first chapter is very it's a very similar chapter to what you do in your O levels as well. So now let's move on to this topic of prefixes. Okay, so remember I said that kilograms, kilo is something different and gram is something different, but of course, again, not in terms of units. But so what does this mean? Suppose or before I go to that, if I say that you have 7x, what does this mean algebraically? This just means that we have 7 multiplied with x. Am I right?
Yes, sir.
All right, exactly. So now let's say you have 2 kilograms. Now this just means where this k is just a prefix, and let's if we look at this table, you can see that kilo is just 10 raised to power 3, which is what? Which is 1000. So you give a name kilo to this number 1000, and the only reason that you're doing this is to make your life easy, because then you can write kilo or K whenever you see 1000. So that's what we do. So what does 2K mean? 2K is just 2 multiplied by 1000. In the similar way how 7x was just 7 multiplied by x. This thing is clear, right?
Yes, sir.
Okay, amazing. So then now if I have to convert from kilograms to grams, all I can do is take this 2 and put the value of K. So I get 2 times 1000. And then what is left? I used K, and the only thing that's left is this G. So I have 2 into 1000, and that's 2000 grams. So I remember, or I know basically some students, they have this problem for converting from one unit to another, and it's sometimes it's like you don't really understand what's happening, but this is what's happening. Similarly, if you think about, if you look at this unit, this thing 1 centimeters. Now centi is a prefix, and you can see that this centi, it's just when you have 10 raised to power minus 2, which is 0.01 in numbers, then this is defined, 0.01 is defined as a centi. Okay, so if I have 1 centimeter, I can simply write this as 1 multiplied by the value of C, which is 0.01. And then the only thing that is left is M, which is meters. So I get 0.01 meters. And that is 1 over 100 meters. So that's where you get these conversions from. So is there any question from this part?
Sir, is there any phrase that you can learn these prefixes easily and the multiplying factor?
Sorry, is there what?
A phrase or something that you can remember easily, the multiplying
Oh,
factor of this prefix.
well, not that I know of, but for me, it was just so that we use it so often, especially when you're doing problems. You'll see these quite often uh, in your problems and all. And at first it appears as though it might be really hard to remember all of these, but once you keep dealing with these things, you get the hand of it.
Also by practice of past papers,
Yeah,
you get.
yeah, yeah,
Okay.
yeah.
Thank you, sir.
So at least not in my opinion, I mean, not in my knowledge, I don't really know if there is any shortcut way of remembering this, but there might be. You never know. It's a big world out there. So yeah. Okay, so moving forward, let's talk about something that's called reasonable estimate. So it's just where you guess and you give the answer, but your guess has to be educated, right? So you cannot make guesses that are just random. You have to have some knowledge for that particular guess. So when you make your estimates, whenever you're making your estimates, it is only reasonable to give figures to one or at most two significant figures, because the reason for that is simply because it's just a rough estimate. It's not an accurate value. It's not a precise value. You just give it to one or at most two significant figures, right? So and that's simply because it's just an estimate. So again, it says since an estimate is not very precise, because again, that's why it's called an estimate, right? So I'm sure that this is clear. So here are some reasonable estimates for some quantities. Suppose you have a mass of 3 cans of Coke, and a can of Coke is typically about 330 ml, and a reasonable estimate for those 3 cans is 1 kilograms. Then you have a mass of a medium-sized car, and a car is always around about a ton or something, and that's somewhere around 1,000 kilograms. And the length of a football field is 100 meters, and reaction time of a young man. So reaction time is basically a time it takes for a person to react, right? And that's 0.2 seconds. This is given for a young man, and it's these are just a couple of examples of your reasonable estimates. So with this, we can look at this problem that we have over here. Estimate the average running speed of a typical 17-year-old's 2.4 kilometers run. So to go about this example, what you have to do is you have to, well, he's asking you the average speed, right? And he has given you the distance. So what do you have to do? Velocity or speed is, let's use V for speed, and it is simply distance covered over the time taken. Now you have this distance S, and you have to compute the velocity. So you need T. So you need to make a reasonable estimate for the time that it takes for an average 17-year-old to, run 2.4 kilometers. So if you think about it, a 17-year-old is running a 2.4 kilometers run. If you these questions are more or less, they're given as MCQs, right? So you can from the options, you can just by looking at the options, sometimes you can quickly guess the correct option. But so suppose 2.4 kilometers, so S is 2400 meters, right? And a good approximation for time would be, you can say it would take him anywhere from 10 to 15 minutes, right? So you can use that, and let's say it takes him 12.5 minutes. Now you multiply this. So let's say 12.5 minutes. So I have to convert this minutes to seconds, and now I'll use the same trick. We know that 1 minute is 60 seconds. So in place of minute, if I write this is just 1 minute, right? This is minute. I write 60. So this is just 12.5 multiplied by 60 seconds. And so it's just converted into seconds, just like that. And so you